All right, the purpose of this video is to introduce Project 3. So recall that Quiz 3 and Project 3 will be due on April 4th at midnight. That's Saturday, April 4th at midnight, okay? And so let's go through Project 3 so I can get you an idea of where to start here, okay? So down here, Project 3, this will be published and available to you soon once I work out the kinks to all of this stuff. So if you click on Project 3, we'll talk about what's going to happen here. Perhaps if Canvas can open it. Let me download it. All right, here's Project 3. Okay, so so I've got two data sets in the Project 3 folder. The first one is called Project 3. It's an Excel spreadsheet. It has 8 stocks and it has daily returns for these 8 stocks over a 2-year period, 2018-2019. So what I want you to do is I want you to calculate the mean, the standard deviation, the skewness, and the kurtosis of these 8 stocks. All right. As you've gone through the lecture outline and gone through the videos, you'll know what these things mean. All right. It shouldn't be hard to do. You can do that in Excel using the information above: which stock is most volatile, which stock has a highest likelihood of having an extreme negative outcome, and which stock has the highest likelihood of having an extreme positive, or I'm sorry, an extreme outcome, positive or negative. So you need to know what those things mean, and they're based on these sample statistics. So 1 and 2, you're going to estimate the return distributions or look at the distribution of returns for these stocks. In problem 3, you're going to grab a new data set. All right. This data set is the risky and risk-free assets. Again, that's going to be located in Project 3's folder. Okay, let me give you a heads up of what this might look like. This is an Excel spreadsheet as well. Give me a second here. So here you have the risky asset from 2014 till present. Here's the risk-free asset. I think I said that. And in column C, you have the risky asset. So you're going to put together a portfolio. So you're going to put together a portfolio made up of these 2 assets. Okay. In order to obtain that portfolio, you need a measure of the coefficient of risk aversion, which you need you need the measure of coefficient of risk aversion. And let's see here. So you have, I've given you information on the willingness for an individual to pay for life insurance. This is how we're going to measure the risk aversion of the individual. And I've given you the probability of insurance claim being filed. Okay. So what you're going to need to do is you're going to need to get the expected return, or in this case, you're going to approximate that using the mean, and the standard deviation of the risky asset. You're also going to need the risk-free asset, and I would just take the mean to get the risk-free, the mean risk-free return. It's going to be very close to 0 at the daily level, but whatever. All right, and then you're going to use the formula that we derived. This is in case 1. All right, the formula that we derive in case 1 to figure out what the optimal portfolio of holding this particular risky asset and this particular risk-free rate. All right. In problems 4 and 5, what we're going to do is we're going to go back to Project 3's data, and we're going to estimate the optimal portfolio weights for 2 risky assets. That's using case 3, and we're going to find the optimal portfolio of Tesla and Netflix. I think in one of the videos I perform, I do an example under the case 3 title. I do an example where I form a portfolio made up of 2 of the stocks in this analysis using just 2019's data. So you'll have access to a video that shows you how to do this. That's case 3. And then in problem 5, we're going to use case 4. What we're going to do here is we're going to account, or we're basically going to form an optimal portfolio. We're going to change the weights to find the optimal portfolio made up of these 8 stocks using 2018 and 19's data, okay? So I also have an example. It's a long example under the case 4 subheading in the lecture outline that shows you how to do this. In your estimation, don't allow for short selling. In that example under case 4's outline, I also show you how to find the portfolio that minimizes the portfolio standard deviation. So I'll have you do that as well in problem 6. So hopefully this has been helpful. This will help you go about solving all of the questions on project 3. Useful stuff, I think.